Well, good morning, good afternoon, good evening, and welcome to our third series of oil and gas related webinars from Endress Hauser. Today we'll be discussing safety in oil and gas. I think a pretty important topic in general. And today's speaker, you see him next to me as well, is Thomas Fritz. And Thomas is our global safety expert and consultant and resides in Germany. He is consulted by our PCs and SCs and customers around the globe on topics related to instrumentation and safety. And this webinar will last roughly about 45 minutes, 30 minutes presentation, a discussion. And today we'll go more into a discussion mode. I think that's a good thing to do as well. And then we go to the question and answer part as well. It's very common in the oil and gas industry to have a small safety moment as well. And today I would like to focus, of course, on the COVID-19 situation. So make sure that you wash your hands on a regular basis, keep your distance, wear a mask in public, get vaccinated when you have the opportunity, and make sure that you stay in good mental health as well. My name is Rob Vermeulen, and I'm globally responsible for the development of the oil and gas industry within the Endress Hauser organization. And I reside on our campus in Greenwood in Indiana, in the US. So, a small introduction, Thomas. You like it? Was okay?
Yeah, it's okay for me. Everything is fine, and so we can start, Rob.
It's a good thing. So, Thomas, when we talk safety, and especially related to instrumentation, there's always one question that comes up, probably first line, first sentence, and that is, what is IEC 61508 and what is IEC 61511? It's in every documentation, it's in every manual, but what does that mean?
Okay, Rob, thanks for the question. The IEC stands for International Applicable Standards. The IEC 65008 and 65011 offer the possibility to introduce safety devices in a structured way. We, as a manufacturer, following I want to say for 97% of all devices that we bring in the market, we follow the IEC 65008 standard, and it's the basis for manufacturers and suppliers of devices for safety instrument systems. And at the same time, it's the basic standard for many other standards they are available. As an example, the railway standard IEC 50128 and 129, or for firing plants, the IEC 50156. So the 65008 is, I want to say, the basic standard for many other things. But for you, and different to 08 and 11 is, the 65011 is used for SIS designers, safety instrument system designers, integrators, and users of devices. Based on the safety lifecycle, all aspects for the implementation are shown and described. Everything is started when you look at the life cycle. It starts with the kind of risk analysis. You do a kind of hazard and risk assessment. You think about the allocation of safety function to protection layers. And you define as the customer the safety requirement specification, and after then do the considers the risk reduction with how you design and engineer the SIS, how you do the installation, the commissioning, and the validation, operation and maintenance, and last, you do a verification that the SIS is doing as you planned in the beginning. So that's that 65008 manufacturer, 65011 end user.
Yeah, so I sometimes get the question, which one is better, 508 or 511? You know, but you cannot compare the two, really, can you?
No, that's they are linked together, very close. So you say that they are really linked. You say in the 65011 you only get the way how to do things, and we as a manufacturer get a guided way how we develop things, and that's the point that we say IEC 65008, it's a must for manufacturers, and the IEC 650 LN for the users, but they link to each other. The requirements are based on this, yeah.
Yeah, so one is more design and one is more proven in use. That's also a kind of thing you hear in the field as well now.
Yeah, Rob, when you are a little bit specific, don't use in the IEC 65011 the wording proven in use. It changed with the latest version that they said for the manufacturer are the proven in use, and for the end user is the prior use state. But it means complete the same. They have the wording change a little bit, but your answer is fully right.
Here's the expert talking, Thomas. I can hear that.
Okay.
Completely. Now, in one of those things, it's also said, yeah, it's very critical to look at the demand mode. So how often can a dangerous situation occur within my plant as well? And I always struggle and say, well, what is high demand mode? Is that once every day? Is that once every week? Is it that once every month? Can you explain that a little bit more and make it practical for our listeners?
Okay, the modes of operation, low or high demand or continuous demand, are defined because different probabilistic failures and analysis methods are used to show the compliance to different tables and data at the end of the day. The definition from the IEC 65011 part 1 is the low demand mode is the mode of operation where a SIF is only performed on demand when it needed in order to transfer.
What is a SIF?
Oh, sorry, it's a safety instrument function. Safety instrument system, the SIS, can have more, 1 or 2 or 3 safety instrument functions. That's a component to fulfill the requirement of a SIS at the end of the day. And the safety instrument function in low demand mode is the frequency of demands should not be greater than once per year. And the high demand mode is more than once a year, to say it on the easiest wording, but the frequency of demands in high demand mode should at the end 100 times greater than the automatic diagnostic test interval of the device. A simple example, if you have a totally test loop internally of a device of 20 minutes, then you multiply this with 100, then you say you have 200 minutes, divide to 60 as an hour, then you have the demand mode, high demand mode for this specific device should not be lower than 33 hours. That means every 33 hours, a demand to the safety function is allowed at the end of the day. And if you have more than that, you come into continuous mode. But continuous mode are not often have use in our industry. It's more in the machinery industry where you have safety functions that permanently available. It's not in our process industry. We are defined low demand mode greater than 1 per year, or high demand mode in the nutshell more than once a year.
Okay, so yeah, that makes sense, I think. If you have a continuous safety situation, you probably designed it wrong, and then you better take a closer look in how to make that from a basic perspective safer than to rely on safety instrument stripping all the time. That's probably not a good thing to do, I think.
The short demand mode of that is because for a low demand mode, and I think on a switch there you have a relay at the end, and you have a lifetime for a relay. You can't use it every 2 hours or something like that. Then the relay damaged sometimes. Yeah. That's the point.
Yeah. There was one question when we did the session this morning. It was like, imagine I have a continuous operation, and I need to make sure that a continuous level is maintained above a certain threshold for cooling purposes or lubrication purposes, and you name it. What should I do then?
Okay. At the beginning, you do with a risk assessment, you determine, among other things, the risk that can arise from the process. And after that, you have to, I will say, think about how an existing risk can be reduced. And at this point, you can make a decision which, and I say C level is needed for a risk reduction for the complete loop. consider the safety requirement specification. When should the safety device be triggered? You have to define the okay status and the failure status where you get an alarm or something like that. And therefore you have to select always the appropriate physical measurement principle, find a suitable installation and perform the seal commissioning and the right way. And at the end, is has something to do with the previous question. You have to think about demand modes, low or high. And at the end, you have to think about all manufacturers give special information to what you have to keep in mind when you do the installation or when you use the device. And a lot of failures are done, information on the safety related signal at the end, and do a seal locking after commissioning that nobody can change things very easily. That's all the things that you have to do.
Yeah, I've seen that as well. You know, those alarms going off in the plant, and then I need to press a button, get rid of that noise and the sound. That's not good. That's not good. But on the other hand, it's causing a valve to close or pumps to stop in order to avoid the spill. You know? Yeah, so make it very practical, Thomas. So if I have a tank which gets filled with a flammable liquid, like a hydrocarbon or a chemical, every 3 days by a tanker or a rail cart, is that a high or a low demand? Every 3 days.
Yeah, okay. But
you're talking year or not year, but now I'm talking days.
Yeah, this cannot be answered so quickly. I am missing some information here from the customer from your side. As an example, do I have a max alarm? I said, do you have a switch on the top of the bottom and the continuous filling process condition are monitored by a level measurement system? Or do I have an extra overfill prevention? In this example, when I have an overfill prevention, we said we mostly like be a low demand mode because the overfill prevention only gets the work to work when the process monitoring didn't work. And in this case, I does not fail more than once a year. So the high overfill protection can be low demand mode, and the continuous measurement system has nothing to do with the safety function. They said, okay, I do the measurement during the whole days. But if you have in the same application only a pump protection, that you say your flammable material, when I have a low, it always be sure that the pump can't run dry under all circumstances, and you have only the switch for pump protection, then you can have perhaps high demand mode. And that's the point. You have the alarm every three days when you fill the tanker, you empty the tank or something like that. That's the reason why you have to think about all the application topics that you have. What is my goal to get the highest safety there? And to say, is it high or max?
You need to use your brains a little bit when you design these things and look at these stuff, and then you can talk to experts like yourself. Huh?
Yeah, that's the point. That's the most important thing in this case.
Now, if you use your instrumentation also a little bit for a safety function, like a flow meter, for instance, to avoid stuff like that, and I calibrate those flow meters on a regular basis, does that have an influence on how safe my instrumentation is in these kind of applications, or has calibration nothing to do with safety?
No, you can't separate it from each other. I want to say the calibration of a measuring device can be used for a kind of proof test under certain circumstances. And in the proof test, you want to detect failures that cannot be detected by an internal diagnostic in this case. So when you do an external 5-point calibration, the function is checked with a reference device, and you know exactly your output signal did give you the right information. Then you can use it as a kind of proof test procedure in your installation. Sometimes you do the calibration of a device to be sure that the value that's coming from the sensor is the right one, and there you check something also for the safety device as well, because you know that the device is doing the job very well. And this is at the end. But when you bring the seal device back in the loop, you have to consider that you should do in regular base a whole test of the whole loop, that you know the sensor get the information to the logic unit and the logic unit go to the actuator and open and close it. That should be also done. You have an influence, and we describe such things in our safety manuals. There are one or a typical kind of proof test could be calibration, if it's allowed to do this. So
Yeah, I mean that's very practical implication of doing calibration and looking. But sorry, I think one point is very important, and that's the statement you made on checking the loop. You don't just check the instrument. You need to check the loop in order to make sure that when there is a faulty condition, that an actuator works and PLC is not by accident stuck in one mode or something like that, because nothing will happen. You can have the best instruments in the world. So you need to look. You need to look at the loop.
Yeah.
So I know you corrected me earlier about my 508 and 511 statement, Thomas. But are there any new regulations, new compliance stuff lately that came out?
I want to say the IEC 65008 and IEC 65011 standards are at a good level. They are really go and describe the things what you are doing. I see that we have more and more attention must be paid on the aspects of cybersecurity. As an example, Bluetooth and wireless communication of measuring devices are increasing more and more, and I like this because it's easy to stand in front of a vessel and do with Bluetooth communication and get information from the device. But here, you should be ensured in any case how external components can communicate with the measurement technology. That means, is it easy to change something in the point? And using as the example of Bluetooth communication, we try to look that we all allow read-only access to the device, that we say we get all the information out, but we can't change something. And that is one easy way to fulfill the aspects of cybersecurity. Or when you have a wireless communication, then you can see we use the password protection, that we say we lock the communication way and only with the correct password you can open it or something like that. And the thing that I correct you at the beginning, that's a kind of definition phase that I said. In the market, you always heard we have proven device things, and this change from the wording, but the topic inside is the same. Now we are on the manufacturer device speak on proven in use, and on the 65011 you have more or less the prior use standard, but that's okay.
Okay, so it's not too bad then. Huh? Now, no. I got a question from somebody who is listening, and it said, I have still devices in my plant. Why do I still need to do proof testing? And how can I calculate the maximum time between the proof tests?
Okay. Yeah, that's a fair question. I always said it's not enough to buy a good device, a seal device from a manufacturer, get a kind of paperwork, and everything is done. That's for me only the first step. When you do all the kind of risk reduction, talk about safety requirement specification, then we come to a point that we say, at the end, we have to prove if that what we are planned really worked in my installation. So the standard described that we have to, in a regular base, a kind of proof test. And this must be carried out in regular intervals to be sure that the SIL level is fit for a long time or doing the useful lifetime. However, the findings from different industries show that proof testing cannot be used as the only parameter. It's important that we fulfill the requirements to the standard to do a kind of calculation. But at the end, we heard that the customer more and more think about systematical failure that can happen in a plant or in an installation. And a systematical failure can be, I have buildup or corrosion in my application, and how can I detect such failures? And this is the only way when you do a proper or the best kind of proof test procedure. And how you can calculate it, there are a lot of formulas in the standards. When you have a link to an NA Namur recommendation, NA106, you find all the calculation there for all formulas for a single installation, for 1 out of 2, for 2 out of 3, and so on, that you come to a PFD average. And the PFD average at the end of the day shows you where you can use it. Is the requirement CO2 really reached? And I will say yes, when you choose the right components, it works very well. And therefore you get formulas in the NA106 and the VDE 2180. There you find hints how to calculate it at the end of the day.
Okay, it sounds pretty complicated to me, but
no, it's really
you have to do up front, no?
Yeah, you have to do it, but it's really to put in the figures from the device and you plan things, and you get at the end of the day a value. It's a, I want to say, an easy mathematical formula, and you can fill your values in, and you get a PFD average for a low demand mode, and then you see, okay, my installation fits for my sea level.
Now, from your experience, I mean, you talk to customers, I go to plants and talk to people as well. If you have to make a choice or a recommendation, you see more and more instrumentation now have functions built in where you can force kind of proof test without taking the device out of a tank, versus, well, I'm a little bit older as well, the old-fashioned way where you take your instrumentation out of the tank, you stick it in a bucket, and you put it back into the tank, and you know whether the system failed or not, and how it failed.
Okay. The best thing what you can do is bring your level in the installation to the triggering point and see what's happened afterwards. That's the best thing. But it costs a lot of time.
Thomas.
Yeah, it costs a lot of time, it costs a lot of money, and I don't like that. So when you put it out and go in a bucket or something like that, yeah, you can do it. But the problem or the difficulty is that you have a systematical failures, you damage something when you remounted it back in the vessel is too high. So that's, I want to say, modern devices have the chance to make a kind of simulation. And then you say you are not close to 100% proof test coverage, but modern technologies offer you the chance to let everything in place and do a proof test button test. You go to the cabinet and push a button and see the reaction of the system, and it's much more easy, and you get a high proof test coverage that you say you bring your installation as a new situation, and therefore you need a calculation to see when it's happened. But at the end, for me, I want to go for new proof test procedures to do a kind of simulation, and it works. And you see in the case of Endress Hauser, the lambda values they are responsible for that are so low meanwhile, and we have so high internal diagnostic that you can do that.
So it's better to do it more often easy than too few times more taking it all out. Let's put it that way.
I want to say that's can be okay. So we have to look on the device that you like or that you have installed in your application, that you see for a CL2 level as a big thumb to say it often helps you to do a proof test, a simulation every 2 years, to be sure that you fit in the value in the lambda value for the seal rate that you have. But at the end, you have to look a little bit closer. For me, it's more or less important that you have the knowledge about systematical failure, and therefore it's much more interested to know what can happen around the instrumentation at the end of the day.
Okay. So another question I got on a regular basis as well. How is the relationship between mean time between failure, which was a very interesting topic about 10, 15 years ago. You know, everybody was looking at mean time between failure. How good is my device? How long will it last? And how long will it be safe and stuff like that? And a SIL rating of a device. Is there a correlation or is it totally separate?
Yes and no. I want to say with the MTBF, you do the halfway of a IEC 65008 development. For ENH, at the end, when we have devices, they are not developed according 65008. I want to say easy switches or something like that. Then we say, we give you a figure that you can have the MTBF, the mean time between failures, and they give you the average time interval of a failure restore cycle of a system. And sometimes you need the MTBF for your calculation program. And that's the reason why we are doing that for non-seal devices as well. For seal-rated devices, for example, we started in a development process with FMEDAs. So at the beginning, we're looking at the safety.
What? FMDA?
Failure mode effect diagnostic analysis. So we are looking really in detail in the main board, and we're looking on the safety path. And then we say, what happened if this component fails? Can the internal diagnostic, a resistor or something failed? So then you can say, did it have this failure an influence on the safety path? Can we detect it automatically, or do we have a failure that we can't detect automatically? And that is the reason when you look in our safety manuals that you get a detailed list of the failure rates that happen for these devices. And this is the difference between mean time between failure. We are looking of a cycle, and in the seal development process, we're going in detail and we're checking what's going on. Is something failed? Can we detect it automatically? Is it a safe failure? Is it a dangerous failure for the safety loop? And this is the point where seal devices is a little bit different to the MTBF.
I can imagine that for a manufacturer that making a SIL device, that the processes and the time it takes for developing, when you have to do all these testing of all these components and boards and the effects on the safety performance of a device is a way more intense process than development of a normal device, sort of.
Yeah, but at the end of the day, when you fulfill requirements for safety aspects, you have to do it step by step. And this is the thing that we said, we did something similar in the past, but not in detail and as documented that we did today or the last 15, 20 years. So that is the reason why we are saying, or I always said, develop devices according to 65008, then you know how to handle things. And you know exactly what you do if you find or get feedback from a market, something happened with a device, how you interact with the customer, give an information or something like that. And this is for me the big benefit when you do SIL development according to something what happens that we did 30 years ago or something like that.
That's true. Now, from a practical experience, Thomas, if you have a high-level alarm, a switch, should I make that switch activate on alarm function or deactivate the output when I hit an alarm function?
That depends on your instrumentation at the end of the day. I always said, look, I have a power off of a device as an example. A power off should be get an alarm that something goes the wrong way. So then you can be sure if you lose the power, that your safety function said, oh, something is wrong with me. Dear Mr. Customer, look at this and that. And that's the reason why I said, I want to say trigger yes or no. That's a kind of of thinking in the background. And you see that's not right or wrong. I always said, look, that you have a safe state when you have a no power on the device, that you know exactly nothing can happen then. And that's for me a thing how you do it. And that's the point at the end of the day. You have to use that what you are familiar with. And when you say, I want to have activate or deactivate, and you can handle the stuff, then it's perfect. For me, only have an alarm mode when the sensor is yeah, not with the power to the sensor. The power didn't go to the sensor, and then it should have the same function as when you have an alarm. And
No.
that's for me the things that you should do.
I think that's an important message. So think about it. What happens if the power would go off? Will it
That's the easy
alarm
thing.
that there is no power on the device?
Yeah.
Yep. And that is, I think, a good thing. Now, if you look at the suppliers nowadays of instrumentation, most reputable suppliers have SIL devices in their portfolio, SIL 2 or SIL 3. Why should I not just buy, if I have a simple, not so critical safety device, not buy a SIL 1 or a 2 device?
Okay.
Is it cheaper?
No, I heard. Yeah, I like this idea. The reason for me is very easy. When you look at the development of a SEAL 3 device, and I say it's the cost-effective things that you can do, and you are on a really high risk. But at the end, during the concept phase, you do a risk assessment in the plant. You think about, you have a safety discussion and following a hazard and risk assessment of the process. And the customer defines at the end of the day the required seal level. And when you have a SEAL 1 as a risk reduction there, why should you use a SEAL 3? I like the idea because we earn much more money. But at the end, you have to think about what makes sense. Redundant design will significantly reduce the cost of proof tests, for example. Then you have to think, okay, I always use SEAL 2 device because SEAL 3 is not happened in my application. And then you can use the same device for every application. But at the end, I make the decision what's coming out of the risk assessment. And then I define the required seal level. And then I put for every component for the sensor side, logic, and actuator side, the required seal level. That makes the life much more easier. But when you want to reduce costs, it can make sense sometimes that you are always choosing the highest sea level. But at my point of view, think about economical aspect that should be taken account in your decision at the end of the day.
Coming to economics, Thomas. Look, imagine I have a little bit of a critical application. No? So I buy a SIL device, so I know the device, the instrument itself is very safe. I always buy good quality valves, that detect whether it's open, closed at the end as well. And then I want to connect it to my PLC.
Yeah.
I don't get happy when you have to buy a safety PLC, Thomas. These things are expensive. Why are these things so expensive?
When I look,
the sensor and the actuator are already safe. I mean, can I not use my normal PLC? These things are pretty good.
Yeah, as well, the standard says you can use a standard PLC, a standard PLC also for safety function. But I'm a little bit, I don't like this idea because it's really easy at my point of view. I want to separate every time the safety function from the process control function. And when you have a process control function and you put the safety thing in the standard, then it could be complicated. Who says what's going on? And that's the same with our devices. The manufacturer from PLC have a lot of work to do. They have a different structure and degrees of redundancy is different. And that's a kind of pricing issue as well that we say for special condition where you have special things, you have to pay a little bit more. And in the topic of PLC, it's much more. But at the end, I always said the failure rates of a safety PLC is clearly lower than a standard one. And this is something to do with the internal structure. But for this information, we should ask a control manufacturer, why is it so? I said, okay, we did the same. They did the programming on a total different way and something like that. And this is coming from that. But at the end of the day, it's a difference between a standard device and an SIL device. And then I go to myself back when I look, it's a cost function, yes, that's it.
Yeah. It's true. And you also have to compare, of course, what would it cost if you would have a spill or something happens, and what would it do to your insurance costs as well if you did do and went halfway instead of the proper way with regards to making sure that you try to do your utmost to prevent a spill and an accident to happen. So that's I think that's very critical as well. Now, coming to one of the last questions I have for you, Thomas. If I buy a device and it has an X rating, an explosion proof rating, or an intrinsically safe electrical rating, these things are normally very safe, right? They cannot blow up, or they cannot start an explosion either, or they can maintain the explosion depending on what kind of safety X rating you're using in your plant. Has that any relationship with the seal or not?
Yes and no. So it's the
Sounds
equipment.
Like German, Thomas.
No, I know that. The problem for explosion protection is the requirement how we develop devices. In the US, for example, you like XD housings, really robust housing, and you have good experience with that. And therefore, we create together, we developed and create and design products. They are fits the requirement for the explosion protection requirements. And this has, in this case, nothing to do with SIL, because in the SIL development, we are looking almost of the failure behavior of devices, internal diagnostic, and the possibility of proof tests combined. And the goal is to develop a device with low lambdas and high diagnostic capability, and not in the first step in SIL to fulfill all protection, explosion protection requirements. These are different. We say yes on the seal. I don't like to say it's a kind of quality parameter that we know how to develop things, produce things, and deliver things. And the C and the X stuff is to fulfill requirements. They are coming from the different countries. You have in Canada and the US totally different approaches how to fulfill a protection mode for a device as we have in the Artex world. And then that's the point. I want to say they are the combination for X and seal certificates is the requirements of an explosion protection and a systematic kind of development and production according to the requirements of the IEC 65008. And that's a combination, and they fit to each other, but you can't say if I buy explosion device, that's the point. They are total different things in the background what we are doing.
Yeah, I think that makes it very clear. These are two different things, and you should separate them, but they are associated to a certain extent, kind of. Yeah. Then I get a question from Ibrahim as well. Can you give us any tips, hints in how to produce or improve work permit procedures for safety devices in plants? So how can I, for instance, improve the proof test cycle, or how to do a proof test?
Okay, for me, the two key points are do the right documentation, describe everything, and train your people that are working with the devices so that they exactly know what is allowed to do and what they should do in a kind of proof test procedure. Then you have to describe bridging the signal from the PLC, something like that, do the test, and afterwards remove the bridge. That should be described, that everybody can do the work in a really safe way, that you know, and this is kind of systematical failures, that you have the systematical failures, the personal behavior a little bit more in concern, or at the end of the day, keep in mind that you do the right things and describe the things. That's both the two things, training and describing of all the topics.
Yeah, and also explaining the why is, I think, very important. because do not underestimate the effects of people that are responsible in doing the proof tests as well. I was once at a plant. It was a chemical plant in this case, and they said, we take our devices out, we put them into the same material as what they are exposed to in a safety environment. So we're doing a lot of testing. But he said, between us and you, he said, we know that 4 to 5% of devices that are put back into the tank or into the application after a safety test was done were damaged during that reinstallment process. So he said, you need to be very, very careful which people do these kind of activities. And it's a mindset in order to make sure that your installations remain safe. It's not just the instrumentation or doing a proof test button, but the people themselves are very, very important fraction that you take them along on that safety journey in how to maintain these installations as well. And there's a reason, their own safety is a reason why we do certain things in this plant. And for me, that hit home because I strongly believe in that aspect as well. So you have all these regulations, all these attempts to make it safer, but it starts a lot with the people and their behavior as well. So training is very important.
We do the same with our internal staff for our service technician that goes outside the customer. We are trying to train them as much as possible, that they know what they are doing and what is allowed and what not, and do the right documentation at the end of the day. What is the service calling is doing and why he is doing, and he know if he did a mistake, what can the problem be at the end of the day. And that's really important, and that's, as I say, documentation and training is the key.
Yep. Then I have the last question. It's a very practical one. It's from Asnil. What happens when we add software in the controls to have a counter that every time a value actuates, so a safety situation occurs, when it reaches a certain value, and a proof test is performed after a certain amount of counts. Let's put it that way. Does that improve a SIL level or a safety level?
At the end of the day, you are responsible for the result, what you are doing. I always said the devices or the latest devices are so good that it's calculation-wise no problem to extend the proof test interval. And when you have a counter that say, okay, I have 5 demands and now I have to test the system if it's worked very well, you can do that. Keep in mind, the calculation-wise is not the problem. Think about all the systematical failure that we discuss, personal stuff, build up corrosion, sedimentation, or something like that. Take into account in this concept what you are planning. But you can do that you say, when you have a demand on a sensor in a seal device, you know it works because you get an alarm, you get the information to the DCS or PLC system, and you have an influence to the actuator. Then you know this device is working. But at the end of the day, you have to be sure if you have no dangerous undetected failure in your loop, there you have to find a way to detect a lot of failures. They are not detected automatically. Yeah. As an example, that's the point. Yeah.
No, I fully agree. So does it reach a higher SIL level? Probably not. However, does it make your installation more safe? Most likely. So it's always a good thing to do. I think that answers your questions as well, Asil. We're running out of time, Thomas. I like the discussion. I think it was very informative. I like to thank you for that. Any last words?
Thank you very much that I can be your counterpart to do this kind of session right now. And for me, it's always the same. If you have a further question, don't hesitate to contact us. And when my colleagues in sales or Rob, who has a lot of experience, can answer your question immediately. So we have the backup, and that's me at the end of the day, and we can give you the right answer later on that. Don't be, I want to say, shy. Ask question to sales and marketing colleagues or service colleagues, and we like to help you to answer the question.
Yep. And you see our names. The emails that we have are very similar. So it's thomas.fritz@endress.com or rob.vermeulen@endress.com. And please reach out if you have questions, you have doubt, or you like to have a discussion, or maybe you want to have a training session on this topic within your plant. Please reach out, and we will try to accommodate in your local language and to the level of the people that you want to train in school in this topic as well. So with this, I'd like to thank you for your time. Next week, we have a new topic, oil and gas related. Same time, same place, and I hope to see you there again. So thank you very much. Have a great day and stay safe. Thank you. And with this, I end this webinar. Thank you.